Alright, so unfortunately I missed Devlog Thursday yesterday, and to explain how that happened, I'll first have to explain how I got here. So it all started after the last Devlog Thursday, as usual. I was still thinking about my CPU when I really should have been ready to transition back to working on my audio program, and I couldn't help myself. I was wondering to myself, how does a processor, or how do certain processors process multiple things at once? Because to my understanding, if you have multiple processes that you want to execute at once, and they're in the same memory, that just doesn't quite work, because you can only access one part of memory at a time. You can't access multiple parts of memory at the same time. And so then I thought, well, what if this parallel process had its own working memory? And I thought, well, what's the point of that? You'd have to be constantly copying stuff over and between the two working RAMs, and that would just be time that can't be spent multitasking. So then I thought, well, what if it was a process that didn't need to communicate with the main working memory and can just be handled on its own with no outside input, and it would be fine? And I thought, well, some processes that might be useful for that are things that aren't affecting what's currently happening right now. Like, for example, drawing something to the screen. Drawing something to the screen and whatever logic is happening in the main CPU really only are relevant to each other at one time. And that's when one has to tell the other what to draw. All the other time, the other thing can be spending all of its time drawing to the screen and maybe doing other processing important to actually making what it needs to draw. So then I thought, what if this coprocessor that I had actually already made while still not entirely clear what it was going to do, this coprocessor could be a graphics coprocessor. And so that's what I did. And that's what's inside there, is a graphics coprocessor. And it's a variant of this CPU right here, except it was copied and placed inside this here CPU, kind of in the early stages. So there are certain instructions that it does not actually have. And of course, there are also certain instructions that this GPU has that the main CPU doesn't have, because they just don't make sense on the GPU. And of course, the reverse, there are instructions that the CPU has that wouldn't make sense on the GPU, like the process to copy memory into the GPU. And so, yeah, that's kind of the division of labor that's going on here, and that's one of the main things that I was working on. A little bit before that, and this was while I was planning what this coprocessor would do, I thought about the problem I was having where, if I scroll up here, you can see the instruction decode logic that's really long. And this is our next topic. I was thinking, well, there's this problem I'm having where in the very first instruction cycle, you can't actually change where the CPU is looking, so you can't actually get or process any data on that first cycle. So I was thinking to myself, is there any way to change that? And there definitely was. And if you see this green line that my mouse cursor is on occasionally flash, what that green line is responsible for is incrementing the program counter during an instruction cycle. And that is so that during the decode part of the instruction cycle, it can increment the program counter so that it will be looking at something else during the execute cycle. And that is how it is now faster, because it can process data in the first instruction cycle. So those are two major things. Then I was thinking, well, man, this is working really well, but this is also getting really complicated. The things that I want to make are going to get really tedious to keep track of, like the code, for example. So if I show you this, there's a lot of things going on here. You couldn't just glance at this. Not even I could just glance at this and look at any particular part and say, for certain, yeah, I know what that does. Because I don't. Like, if I put my cursor right here, what is that 0, 0? Well, I'm fairly certain that it's not an instruction, because the 0, 0 instruction is a no operation instruction which does nothing. Maybe that B7 is an instruction. But no, actually, the instructions don't go that high. So it must be that 0, 3. Oh, that's a jump instruction, which means, oh, okay, so that's where you jump. See, this is so convoluted that it's just impossible to keep track of. So I thought, well, what's something I can do to overcome that? And I thought, an assembler. I'll make an assembly language for this, and I'll make a program in Unity to convert that assembly language into machine code. And that's what I did. But I'm not going to show you it because the program itself looks really... There's nothing to look at. Everything it does is invisible. It takes something from a file that looks something like this and turns it into a file that looks something like this. Now here we are. This is the nice convoluted walls of text that we're nice and accustomed to. But the nice thing about this is it's actually separated by instruction, where the first line or the first column is always the opcode, and the things after it are always the operands. So that's way more convenient than something that just looks like this. So that I can actually do a little bit of debugging myself after I get this file. And at this point that I am currently at, I am 100% confident that both the compiler and CPU both work perfectly, so I can rest assured that any code that I put into the compiler, as long as the code works, will work. And so that's taken a lot of stress and worry out of this whole process of programming for this CPU. But then came the ambition, as always. So I was thinking, and I think this was the day of Devlog Thursday, the morning of Devlog Thursday, I thought, there's some important, significant changes that I really want to make to this, both the compiler and the CPU, before I do this episode. And I did not get them done in time, because most of my time was spent making those changes on the CPU and then making the changes to the... I keep saying compiler. It's actually an assembler. I made the necessary changes to the assembler to actually make that code something it could recognize. And of course, it was also a new feature that I was putting into the assembler that was completely different and completely unique to the assembler, so I had to make it work before I could even use the assembler. And it didn't work on the assembler the first try, so eventually I did get it to work, but then turns out it didn't work on the CPU because there were some problems that I had. There were some mistakes that I made inside the CPU. So I spent quite a while, and I think, it was last night, so Thursday night, that it was 1 a.m., I think, that it was finally working, and I'm so happy, but it wasn't Devlog Thursday anymore. In fact, it was, so it's 5 now. It was just several, so 5 plus, 11, I don't know, I can't do math. So, it was technically today, this morning, that I got it finished. And it works. And that thing, because I haven't actually explicitly said what that thing is. So I'll go ahead and tell you. But I actually also kind of want to show you. So you can see that I've got Word open. They kind of recently changed their little logo for it. I think I kind of like it. I like it a little bit better than the old logo. It looks slick, I guess. Anyway, I have this really fancy Word document that's even got my little logo. That's not what I actually look like in real life. But it is the programming documentation for the XE2020 8-bit microprocessor with integrated graphics coprocessor. Really nicely formatted, got a table of contents, and this... here's how it works. I just scrolled over that. Not like it's important. This is the huge table of instructions with helpful information like what they are, what their opcode is, what they do, what operands they have, and where they work. So you've noticed that I've got CPU plus GPU for the large bulk of the instructions, but then you've got this point of divergence. Because these instructions are listed in the order that they were created, and they're also processed in the order that they were created, because it was the order of creation that is how they were created. I excuse my mastery of the English language, but this is where it starts to divert, and we see this big block right here of instructions that are only on the CPU. And then we see this block right here that don't even actually exist. It's actually 2, but So yeah, adk, subk, mfk, divk, lidp, and ump. So what do these things do? Well, these ones that end in C, these are variants of the arithmetic instructions that support carries, or borrows. So borrows fit subtraction. And the main ones, which are all the way up, I passed it, up here, they generate carries, but they don't use them. These ones do. And that's so that I could do arithmetic on, bigger sized numbers. Numbers bigger than 8 bits. Which I still have not actually used. And there is the slightest chance that those instructions don't actually work. But that's not important. We also have this debug instruction, which stands for debug. Of course, all of these stand for them. I was just being stupid. So this outputs a value to the debug bus. Well, what is that? If I go over here, you can see that this right here is the debug bus, and this is the debug value. I was using that because my code wasn't working, and I'm like, I'm pretty sure I did it right, but no, I actually didn't do it right, as usual. Of course, then we've got this HLT, which stands for halt, and it completely halts the operation of the CPU. Operation cannot be resumed. That was another debug instruction. That was my really, rudimentary debug instruction. Just stop everything when it gets to a point that I need to look at what's going on inside. So that was back when the CPU was still unstable and not completely working. But now that it is, hopefully including these instructions, now I can just output a value whenever it gets to a certain part of execution. Of course, there are these 2 instructions that do not actually exist. They are planned. I dread having to try to implement them, but they would be really useful, probably, because they are jump subroutine and return. And jump subroutine is a jump instruction that is unique in that it stores a return address, which is the address just after the jump instruction itself. And this RET, or return instruction, will jump to that return address that's stored. So that you can have a certain part of code that relies on other places in memory that doesn't have to be copied for every place that it's used. It can just be the same piece of code that's reused and reused over and over again. That's a common thing in programming. That's a really efficient way to program. That's really the way to program. It's called a subroutine. And you want to make things in programming as efficient as possible. Reuse everything you can, and these 2 instructions would definitely support that paradigm, but unfortunately, they're not implemented yet because, well, I just had a really traumatic time getting the rest of it. But anyway, there's also, I showed you a quick glimpse of this assembly code. If I go up to the very top, we can see, well, some things in green. Those are called comments. Those are not actually assembled at all. They are just there for readability. Then we've got these things with question marks. Those are pointers. The names after the question marks are substituted for these numbers. So any place that these names occur with a $sign in front of them, like this $joy1y, actually gets replaced with FF81. And that's just to make things easier. So I don't have to write all those numbers and remember what those numbers pointed to. And then, of course, we've got these orange things, which are labels. We've got this number sign, or pound sign, or whatever you want to call it, but not a hashtag. You cannot call it that. I will not let you. It is a label. It points to the address of the instruction directly after it. So this check move X, if it's ever used with an @ symbol right before it, like this @ move right, it will point to this instruction right here. And this @ move right will point to the instruction right here. And so yeah, those ones with @ symbols are only valid in jump instructions, and the ones with $signs are only valid in instructions that take addresses as operands, excluding the jump instructions. In fact, that is literally specified right, yeah, because there's an assembly language guide that I made that's specified right Where did I specify it? I don't remember. Oh yeah, I think it's right... Where? No, I don't know. Where did I... Oh, here it is. It's specified right here. Refer to pointers declared in the program and are only valid and instructed to take addresses of operands, excluding jump instructions. Yeah. So anyway, that's everything I've been working on. Now, I hate to have made you wait so long, but I'll show you what is working. And this has been running for a really long time, but it's fine. So I've got these little controllers right here. These are game controllers. They're exactly what I just said they were. So if I move this joystick, which that's what that is, to the left, then this circle will move to the left. Hopefully. Wait, what's the tick speed set at? Oh, okay. There we go. No, okay, I didn't hold it for long enough. If I move it to the left... There we go. It takes a while to respond to inputs. There's probably some things that I could do to make it more efficient, but I'm not sure what. It just may not be running as fast as it possibly could, because even though I've set it to 4.1K, it's probably running somewhere around 1 to 2, or maybe even worse, because I've got OBS running. But anyway, yeah, that's what is implemented. I can move this cursor around this tic-tac-toe grid, and soon I'll be able to press A, probably, and... Okay, I guess I didn't hold that down long enough. There we go, okay. I'll be able to press A to place... I think player 1's probably going to be the X's. I'll place an X there, and that'll be my first move. And since AI is going to be a pain, I've decided not to do it. So that's why there's a second controller, so that player 2 can fight player 1, you know, like the good old-fashioned way. They don't need no AI, because AI's hard. But yeah, that's everything that I've gotten done so far. Thank you for watching up to this point. I don't know how long this video has been, but I'm about to find out, because for some reason pressing the end button, which is supposed to be my stop recording button, doesn't actually work. I have to go into OBS like this. To go into OBS, I have to hit this button. So, bye!